The fifth and final method we have for proving triangles congruent is HL, which stands for the hypotenuse leg theorem. This theorem will only work if you have a right triangle. So this theorem does not work on all types of triangles like the other ones. You can use any of the theorems, SSS, SAS, ASA, AAS, on any triangle, right triangles, non-right triangles. Any triangle can be proved with those four theorems. HL is special. It's only for right triangles. So it says, if the corresponding hypotenuses and either leg of two right triangles are congruent, then the triangles themselves are also congruent. So you need to have a right triangle to start with. That's important to keep that in mind. You can't use HL on a triangle that doesn't have a right angle. The hypotenuse, keep in mind, is the side that is the longest. It's also the side that's across from your right angle. And then as long as the two corresponding legs are marked congruent, then you can say that the right triangle is congruent. So if you look closely at this, we have one pair of angles that's congruent and a pair of sides. So you can see that this is actually ASS congruency, which normally does not work, but in a right triangle, it does, but only in a right triangle. And we don't call it ASS. We're not going to write that on our papers. We're going to write HL. So again, this will not work on triangles that aren't right. Will only work on right triangles. However, a right triangle can be congruent by any method besides HL as well, because those theorems and postulates work on any triangle. So let's review real quickly the types of triangles that we have. So we can group or classify triangles by their sides. The three ways are we could have an equilateral, an isosceles, or a scalene triangle. In an equilateral triangle, we have the word equal, which means all three sides are equal or congruent. In isosceles, we have two of the three sides congruent, and in a scalene triangle, none of the three sides are congruent. We could also classify triangles by their angles. If all three angles are congruent, then we would have an equiangular triangle. A triangle that is equilateral is also equiangular and vice versa. So they're exactly the same type of triangle. Their angles, because they have to add up to equal 180, would all be 60 degrees, 60, 60, 60. So an equilateral triangle, we can assume, is also equiangular and vice versa. An obtuse triangle is a triangle that has at least one, not at least one, that has one obtuse angle. Can't have more than one obtuse angle or else it won't make a triangle. And a right triangle is a triangle that has one right angle. And an acute triangle is a triangle that has three acute angles, or three angles smaller than 90 degrees. So there's an asterisk if you notice up here on isosceles, because we're going to talk a little bit more about isosceles triangles in this unit. Isosceles triangles have some specific vocabulary that is related to them. The two congruent sides of an isosceles triangle are called the legs, and the bottom and non-congruent side is called the base. The angles also have special names. The angle that is at the top or is formed by your two congruent sides is called the vertex angle. And the angles that are formed by your base and the legs are called your base angles. It's important to note that base angles are always congruent. So when we see that we have two angles congruent in a triangle, or we have two sides congruent in a triangle, we can assume that it's an isosceles triangle, which gives us a lot of information. In addition to both these legs being congruent and these two angles being congruent, it also tells us that essentially our triangle is symmetric with a line of symmetry right through the vertex angle. So what that's going to do is basically create kind of a mirror image. So whatever is true on one side will be exactly the same or correspond on the left side or on the right side. So whatever's on the left will correspond with whatever's on the right and be congruent. This line of symmetry will also be perpendicular to the base, creating two 90-degree angles. And is there anything else? It will bisect your vertex angle as well. So again, line of symmetry down the middle, which basically ends up giving us a lot of information about our isosceles triangle.